and welcome. Hope you can all hear me. And welcome to this talk, an introduction to Kubernetes. First of all, I would like to thank Lutze, as I think it's pronounced in German, for this conference. I think it's really awesome. It's great to be here. The weather is a bit warm for my liking, but that's how it is. I would like to start by telling that this is an introduction to Kubernetes and seeing some of the other talks about service meshes and optimizing the core kernel for networking stuff. So if you're doing any of that stuff on a regular basis, this is probably not a talk for you. This is an introduction to Kubernetes. The reason why I wanted to do this, and I've done a lot of these, especially in Denmark, is because I think it's very important that we get everybody on board. And everybody should have a good chance of getting an introduction to this topic, because it's extremely important to me, at least. I think Kubernetes is a big part of the future. Yeah, and one of my goals today is to try, if possible, to teach every one of you at least one new thing today. So I'd like to know how many of you in here, except for Casper, knows how to pronounce Kubernetes in Greek. This might happen. Because Kubernetes is a Greek word. Google is really good at taking words and just stealing them and mispronouncing them really badly. The thing is, I had a colleague from Greek, and he laughed every time I said Kubernetes. It's pronounced Kivenidi in Greek, as far as I know. And it means helmsman, the person who steers the wheel on a ship, as far as I know. So yeah, let's dive into it. This is me. So now you know what I look like, so you can find me after this talk if you want to talk to me. That's always good. I have a CKA. It's nothing really to brag about, but I think it's important to show that this is actually something you should take. It's a really good exercise. It's a good way to get to know Kubernetes and some of the fundamental mechanics of it, the objects and how they relate to each other. I do a lot of training and consulting. I have basically two branches of work. One is everything cloud native, and the other one is Atlassian. So they don't have a lot in common, but yeah, that's what I do. And then I help out as a co-organizer in the meetup group for Cloud Native Aarhus, and we actually joined the Nordic meetup groups in the Cloud Native Nordic. Sounds like a design company, but it's not really. Yeah, so that's me, and that's my Twitter handle. I'm on Twitter now, because apparently you have to be there. So, yeah. In my spare time and when I work on a project called ESK. I was stationed in Stockholm. That's not in Denmark. I'm from Denmark. And I was sitting there at the hotel at night, boring. There's no windows on the -2nd floor. So I started this project where I merged my two interests, Kubernetes and Atlassian products. So it means Atlassian software in Kubernetes, and it's open source, of course. So we open sourced it in Barcelona at KubeCon. So please, if you're interested in that, help out. We accept pull requests and issues and everything. This is the URL for it, if you want to know about it. Okay, so why Kubernetes? Well, if you asked me like 1 or 2 years ago, there was this big battle of the orchestrator. There was like Mesos, there was Swarm, Docker Swarm, and there was Kubernetes. That war is over. Kubernetes basically won. There might be some special applications for Mesos still, but in the bigger picture, Kubernetes won that battle by far. But in this slide, I'll try to tell you why I think Kubernetes is important and why you should consider it. There are many other good reasons. But if we go back in time, so I started out with a Commodore 64, and then I got a 286 with 1 megabyte RAM and 40 megabyte hard drive and a processor with 1 core. So we made a program that would create a process, it would use the core, everything worked beautifully, right? Really awesome. Then they made these processors with 2 cores or 4 cores, and then our application was basically running slower, right? So how did we solve that? We made threads, right? So for instance, in Java, you can create threads and you can utilize the CPU better. And that problem is the same we're facing today, but on a different scale. Because now we have a monolith, but we have a lot of machines we want to run it on. So how do we do that? So it's basically the same position, right? So in my opinion, 2 ways you can go about, and you can actually combine them, and many people do. One of them is doing horizontally scaling a monolith. The other one is doing microservices, right? So basically take your application and spreading it out over your IT infrastructure landscape. And then you can also horizontally scale each component or service. The thing is, you need to orchestrate this. It's not easy to actually automate this. There was this whole era of configuration management. Didn't really scale. So for me, a lot of the reasons for Kubernetes is if you want to scale, because it can. It's built for it. It's built by Google. And a lot of the practices that comes along with Kubernetes is because it needs to scale. It supports scaling, like design for failure. If it didn't have that, you couldn't scale, at the scale of Google at least. So it's a lot easier to orchestrate these kinds of scaling if you have an orchestrator to do it for you or help you. So that's my main reason to look into Kubernetes. I have a background as a system administrator, so I'm a bit biased, I guess. Okay, so sometimes you need to be humble, and in this case, there's a good reason for it. Kubernetes is an open source project based on a product inside Google called Borg. Later on, something called Omega, and it's very nerdy. Borg is from Star Trek, a sci-fi thing, and these things had a collective, so everything was connected, right? And if you noticed, the Kubernetes logo has 7 sides. Does anybody know why it doesn't have 6 sides like every other Google logo? Anybody? It's a bit strange, right? It's because in one episode in Star Trek, some Borgs crash-landed to a planet and got disconnected from the collective. And they created their own collective locally, so they wouldn't go insane. The Borg who initiated that collective was called 7. So slightly nerdy. The other thing we got is basically the catalyst for all of this, and that was a company called .cloud, or Cloud. Can't remember. And they switched to the name Docker, and they created the Docker, made it easy to build and ship and run containers. Containers have existed for a long time, but they actually made it easy. And that was actually the catalyst for creating Kubernetes as well. So, yeah. So in this talk, usually when people do an introduction to Kubernetes, they start with a big picture with all the objects from the top, like ingress, deployments, and all that stuff, and then they drill down. I would like to take the opposite approach in this and see how that goes. So I think everybody can relate to an application, or at least a box with the wording application, right? You have some code, you need to run it. And what everybody knows, I hope, is that we can put that in a container. It's an abstraction for namespaces and C groups and all sorts of stuff, and packaging. And then we can put another abstraction on that. And in Kubernetes land, it's called a pod. A pod is one or more containers, and they share the same resources. So localhost for each container in a pod is the same. If one dies, they all die. You don't schedule anything smaller than a pod, right? And the way you define this is with YAML, because why not? The alternative is JSON, so I guess that's why. And this is a very small example of a manifest for a pod. And you can see that this is our pod, so that's the abstraction. And we have a container defined, and we have our application as well. This is a very simple example, of course, but I hope you get the picture here. Yeah, so this is how we define our desired state. So if you use Ansible, you would tell the commands to achieve something. Here you tell the system your desired state, and the system will try and make that happen for you. Yeah. So next we can say that we would like to have some kind of storage inside our pod, right? So again, we have a pod with a container, with an application. And what we do is we specify a volume for a pod to use out here, the red one. And then we can actually attach that or mount that into a container. So if you have 3 containers in a pod, you can define it at pod level in the spec, and then you can use it in the different containers wherever you need it. Again, the YAML here for the pod, you can see we have defined a empty dir, which is a no-go. You shouldn't use that, but this is an introduction, so we keep it simple. And this is in the spec, so this is the pod level. And then we mount this into our only container in our pod at a location /cache. And we reference it by name. Okay, awesome. So now we have a pod, and that's basically what the kubelet understands. And I'll get back to the kubelet later on. Everything from here on is centralized, right? So now we would like to replicate our pod or our application. We'd like to be able to scale horizontally, get more of the same thing running. So we can do that with a replica set, basically an object inside the API server. And it's just another abstraction on top of that. And Lord and behold, we get some more YAML. But it's really simple if you draw these boxes with colors. So you can see we still have our pod, that's the gray area, and we have a container, that's the blue one. I hit the application because it was getting messy. Now, the replica set gets a name, and it has some metadata where you store the name. You can put some other stuff there. And then in the spec, we tell it how many replicas do we want. This is our desired state. And then we put in a selector, so that's the way service discovery works in Kubernetes. We use labels. And you make a selector that says everything that has these labels belongs to me, or is attached to me, or have a relation with me at least. So in this case, we want 3 replicas of our pod, so it'll spin up 3 pods of this in our cluster. If we change our mind and say, now I want 4, a controller will react and spin up a new one. That's the replica controller. Okay. So here you can see I've deployed a replica set, and now I have a desired state is 3. I don't have anything running yet. None of my pods are ready. 6 seconds. So a bit later, you can see that my desired state is 3. I've currently 3 running, and they're all ready. So they're reporting, I'm ready, I'm healthy. That's 18 seconds later. The thing is about replica sets, in the old days, you had replica controllers, RCs, and that was basically the highest abstraction you had. If you wanted to do a rolling update or canary deployment, you would have that actually happened on the client side in kube control. And I say kube control, there's a battle, it's not kube cuddle. I'm sorry, it's a hobby, not a fetish. So I changed my mind here. So what we want is another abstraction for rolling out, creating a rolling update or canary deployment, rollback, and so on. And that in Kubernetes is called a deployment. It's just another layer in the onion. So the controller for the deployment will create a replica set controller that will create your pods, that will have your container start up on a node with your application in it. Right? So we built on top of everything. And yes, we get YAML. So here we have YAML where you can see that we define the replicas. That will go to the replica controller. We have our pod template, how do we want to create our pods. And we have a containers, and then we have some stuff for the deployment. In this case, a strategy, where we say we want a rolling update strategy when we update, we change our mind, right? So you can set max search. I mean, this means how many can you add before you remove stuff, and then you have max unavailable. How many can you take down compared to what my desired state is at the time? So rolling update is that if you have 3 pods running and you want to deploy a new version, then instead of taking down all 3 of them and deploy 3 new ones, you can actually deploy a new version, take one down, deploy a new version, take one down, deploy a new version, take one down. And then you have 0 downtime upgrading, right? And that is what you use the deployment object for. And there's a controller for that. Awesome. Are there any questions so far? Super. So here you can see kube control get deployments. And I get some information about my app pod deployment. I've desired of 3 replicas. I still don't have any. None of them are up to date, and none of them are available. This is after 1 second, so I think that's okay. But then a bit later, you can see the desired state is 3. I currently have 4 running. They're all up to date, and they're all ready and available to retrieve traffic. I'll be sharing these slides, and if you haven't noticed, at the bottom here, there's a link to the subject on each slide, so you can find it if you want to dig deeper into this. Okay, so if you want to upgrade your deployment, you can simply say, I want to set the image of the deployment my app pod, and I want to set the container image to this BusyBox version 131 now. That'll actually kick in this rolling update mechanism. There's this, and Kubernetes is made up of, as I told you, the pod spec is handled by the kubelet on every node. Everything else above that is handled by control loops in the controller manager. So that happens centralized. Okay, great. Another thing you can do with Kubernetes is like with Apache, you can create virtual hosts. In Kubernetes, you can create namespaces, basically, so virtual clusters. So you can have a production namespace, a staging namespace, a Git share namespace, or whatever you want. So one of the cool things is that if you want to build ephemeral environments, you can do this with Kubernetes extremely easy. So if you have a new commit, you can create a namespace with a Git share, you can deploy your stuff, run your test, remove it again. It's super easy to set up and deploy. And here you can see I have 3 namespaces with different pods running, and I can run my test on them, and I can do whatever I want. Okay. So now we have a deployment running that creates replica sets, that creates pods for us, that houses our containers with our application in it. I would like to be able to communicate with this service. So let's say I have another service in the cluster, and I want to communicate with my deployment. So what you do in Kubernetes is you create a service, basically a proxy load balancer thing inside the cluster. And so let's say we have our 2 pods. We have replicas set to 2, so we have 2 identical pods. Then we create a service. It's a separate object. It'll create endpoints that points to each pod that you have running, right? And this will be updated automatically, real time, every time you change stuff. So if you delete a pod, it'll update the service, and it won't send in traffic to that. If you add another pod, it'll update it as well, and it'll get 3 endpoints. Yeah? And this is the YAML for a service. You can see we have a kind service. We have a metadata with a name in it. We have a selector. This is where the endpoint finds the pods. And then we have the port and the protocols that we want to hit. So in this case, I want the service to expose port 80, and I want it to hit port 80 on the pods as well. Now the good thing about, oh yeah, sorry. Here you can see how it relates to my deployment. So I have my labels inside this template, pod template, and that's what will connect the service to the pods in the end. The good thing about the service is that you don't just get an IP address inside the cluster for your service, you also get a DNS name. And you can use the short name, it's just the name of the service, or you can use the fully qualified one. And if you want to use the fully qualified one, the default is the name of the service, and then the namespace, and then svc.cluster.local. Then you'll hit your service. So in this case, I'll just curl my application. What happens here is that, behind the curtain, is that actually, from the service in the cluster that is running this curl command, it'll actually be resolved to localhost and hit the kubeproxy process on the worker node. And that will actually DNAT it to the real service where it's running. And kubeproxy has one job, and that's creating a lot of IP table rules, but ensuring that every node can resolve every service in the cluster and hit those endpoints, right? So that's the manifestation of your service, basically. Yeah. There are different types of services. There was one person on this stage who showed a type load balancer. There are different types. The first one is cluster IP, and if you choose this type, your service will get an IP inside the cluster. You won't be able to use it from the outside. The funny fact about cluster IP is that if you actually set a value to this cluster IP, you can do that. It's not advised, but you can do that. But if you set it to none, the service will actually be headless. So that's kind of cool. And we use that in the project that I'm working on. The other type is node port, and in this case, your service will be exposed on every worker node on a high non-privileged port, 30,000 something. And that means that you can set up a old-fashioned non-cloud native load balancer and just hit that port on every worker node. And kubeproxy will then route the traffic to the actual pod. Then we have external name. That's one of the new ones. So imagine you have a database outside your cluster and you have a service inside the cluster where you need to connect to this database. Instead of hardwiring the DNS or IP in the pod, you can create a service and have an external name, and that will resolve the external IP address. Why would you want to do that? Well, if you change the DNS or the IP of the database, you would have to redeploy your application to make that change. In this case, you can just change the service, and everything will propagate out, and it'll work immediately. And then we have type load balancer. This is if you run in a cloud environment, usually. It will kick off a cloud controller that will create a load balancer in Google or AWS or Azure or Azure. And yeah, so they have a controller that will react on objects with this type. There's a really awesome project called MetalLB where you can actually, on bare metal, create load balancer or services as type load balancer and get an IP on one of the worker nodes. I have that on this machine right now. Yes. So the architecture. So we have some worker nodes. On these, we have more or less two processes. There are more, but these are the most essential ones. We have the kubelet. That's the one that creates pods, basically. And then we have kubeproxy. That's the one that creates the service network and the routing for that. Then we have the API server, which is basically a REST endpoint or a server, REST server. These processes connect to the API server, and they just listen. The API server saves its state in a storage, in this case etcd. It could be console as well, but in most cases it is etcd. And then we have a scheduler, a process running with all with a control loop that listens for pods that doesn't have a node assigned to it. And if it finds that, it'll find a node for it, a suitable node, and put in the node name. So it won't actually talk to the node and tell it to start it. It'll put the value back. And then the kubelet will react, because now there's a pod assigned to that node, and it's not running, so it'll start it. So it's a very decoupled architecture. I like it a lot. And then we have the controller manager. This is where all the controllers live. So I talked about the replica controller, a replica set, and the deployment controller, and so on. So this is where they live. There are more controllers, and hopefully I'll have time to show you one of them. And it's also connecting to the API server. And then, when this is all up and running, we can actually start pods, and we can kill pods, and then it'll spin up new ones, and it'll self-heal and design for failure, and basically magic. Right? Super. So there's a lot of stuff I can't cover in this short time, but some of the stuff that I think you should look into if you're new to Kubernetes is, like, for instance, config maps and secrets, a way to define a configuration, either as environment variable or a file that you can then treat as a volume and mount into your pod. The same with secrets. They encrypted it with base 64, which is not encryption, but yeah. You should also check out PV and PVCs. Those are not Pokemons, but persistent volumes and persistent volume claims. So PVs is basically defining a storage, and PVCs is defining a claim of that storage. And that claim you can use in a pod. That's the right way of doing it. We have ingress, basically defining an object in the cluster on how you want to route traffic from outside the cluster to your service. And then you have something called an ingress controller, a load balancer or proxy that can understand ingress objects and reconfigure itself all the time. So it'll act just like a controller, listen to the API server, and reconfigure everything every time something happens. A good place to start is traffic. It's a very easy ingress controller, but most load balancer or proxies understands ingress nowadays. Nginx, HA proxy, and all that. And there are other controllers. You can create cron jobs, you can create stateful sets for stateful applications, you can create daemon sets. So if you want a pod running on every node, you don't know how many nodes you have, and it can change. So you can create a daemon set and say, I want one of these running on every node. And then every time a new node is spun up, it'll deploy a pod on that. So that's what I had. Now, we have 5 minutes left. So what I wanted to do is show you what I've been playing with. So here you see my cluster. I hope you can read it. You can see the namespace. That doesn't work. See the namespaces. We have Ingress Nginx. We have Jira Production, Kube System, Metal LB, and so on. I have my nodes. I have 2 worker nodes. They have some roles. And then we can access our application. In my case, the Ask project can provision a Jira, either to server or data center. And if you look closely, you can see I have a Postgres and a Jira. Now, I've changed my mind now. So now I want to scale my replica set, or my stateful set, sorry, and I want to set the replicas to 2. And now Kubernetes will react, and the replica set controller will react, and it'll create another one. So now I have 2 Jira running in the same namespace. And because I'm using a stateful set, they keep the identity. That's the very important thing about stateful sets. Deployments are more for stateless applications that you can just spin up and throw away, where stateful application or stateful sets are more for sensitive applications, in this case Atlassian. So, and another thing you get, so this is Jira, if you run Prometheus, is that you can scrape metrics. And in this case, I actually scrape both the cluster, so you can see I get some information about my cluster. You can do alerting on all of this. That's really awesome. And then there's a guy somewhere who made a free open source plugin for Jira that exposes Prometheus metrics, so I can actually get, something is failing now, but that's how it is when you do demo. Like how many licenses do I have in Jira? How many have I used? And then I can do alerting on this. And that's quite important for people who manage these kind of applications. I get information about the Java or JVM inside the Tomcat in the container. How much memory is it using? How many attachments do I have? All that stuff. And you can do alerting on all of these metrics. And you can go back in time and see when it changed, when did we suddenly use more licenses and everything locked down. So I think that's really awesome. And I think we have a couple of minutes left for questions, or do we want to just see more fun stuff in Kubernetes? Are there any questions? Yes? Oh, there's a microphone. Oh, we need sound. Yeah, so all of these concepts are Kubernetes concepts. Volumes, pods, deployments, replica sets, those are objects inside the API server. Then you have all the mechanics of Kubernetes, the thing that reacts, and that's the controllers, the control loops. Yeah, I think that's my best answer. Okay. Are there any other questions? Okay. I hope you enjoyed it. I hope you survived the heat. And thank you so much for your time.